So hello everyone, welcome back to my channel. My name is Anthony G. Tolosa. So for this day, we will summarize the activity 8 of the networking one, which is in ATACAD. So but before that, we need to read the the introduction of this chapter. So chapter 8, subnetting IP network. So designing, implementing, and managing an effective IP addressing plan ensure that network can operate effectively and efficiently. So this is especially true, excuse me, as the number of host connection to a network increases. So understanding the hierarchical structure of the IP address and how to modify the hierarchy in order to more efficiently meet routing requirements is an important part of planning an IP address schema. So in the original IP version for address, there are two levels of hierarchy, a network and a host. So these two levels of addressing allow for basic network grouping that facilitate in routing packet to a destination network. A router forward packet based on the network portion of an IP address when the network is located. The host portion of the address allow for identification of the destination device. So, however, as network grew with many organizations adding hundreds and even thousands of hosts to their network, the two-level hierarchy is insufficient. So, subdividing a network adds a label to the hierarchy, creating in essence three levels: a network, a subnetwork, and a host. So introducing an additional label to the hierarchy creates additional subgroup within an IP network that facilitate faster packet delivery and added filtration by helping to minimize local traffic. So this chapter examines in details the creation and assignment of an IP network and subnetwork addresses through the use of the subnet mask. So we are done in reading the introduction of this chapter. So we go to the last topic, which is the summary and the conclusion of the chapter 8. So So the process of segmenting a network by dividing it into the multiple smaller network spaces is called subnetting. So every network address has a valid range of host addresses. So all devices attached to the same network will have an IP version for host address for the network and a common subnet mask or network prefix. So traffic can be forwarded between hosts directly if they are on the same subnet. Traffic cannot be forwarded between subnet without the use of a router. To, to determine if traffic is local or remote, the router uses the subnet mask. The prefix and the subnet mask are different ways of representing the same thing, the network version of an address. So IP version for a subnet are created by using one or more of the host bit as network bits. So two very important factors that will lead to the determination of the IP address block with the subnet mask are the number of subnet required. So at the maximum number of hosts needed per subnet, there is an inverse relationship between the number of subnet and the number of the hosts. The more bits that are borrowed to create subnet, the fewer host bits that are available. Therefore, there are fewer hosts per subnet. So the formula 2 to the n, where n is the number of host bits remaining. So it used to calculate how many addresses will be available on each subnet. So however, the network address and broadcast address within a range are not usable. Therefore, to calculate the usable number of addresses, the calculation 2 to the n minus 2 is required. So subnetting a network or using variable length subnet mask BLSM was designed to avoid wasting addresses. So version 6 subnetting requires a different approach than IP version 4 subnetting. So an IP version 6 address space is not subnetted to conserve addresses. Rather, it is subnetted to support a hierarchical logical design of the network. So while IP version 4 subnetting is about managing address scarcity, IP version 6 subnetting is about building an addressing hierarchy based on the number of routers and the network they support. So, careful planning is required to make best use of the available address space. Size, location, use, and access requirements are all consideration in the address planning process. So, after it is implemented, an IP network needs to be tested to verify its connectivity and operational performance. So the chapter 8 is all about the subnetting of an IP version 4 network. So we all know that subnetting is a practice of dividing a network into two or more smaller networks. So I will show you a video that will show the on how to subnet an IP version 4 network. Okay, ting.
Hello, and this is Sunny. Welcome back. Today my topic is subnetting. A subnet is a logical subdivision of IP network. The process of dividing a network into two or more networks is called subnetting. The main purpose of subnetting is to help relieve a network congestion and improve network performance. Security is another benefit of subnetting. Besides, your network professor may test you about subnetting. CompTIA National Network Plus certification also expects you to know how to subnet. However, some textbooks make subnetting very complicated and confusing. In this video, I will use a very simple way, Sunny way of subnetting. And after this video, you would find subnetting is not difficult at all. However, in order to understand subnetting, we do need some basic knowledge such as subnet mask, network ID, host ID, and broadcast ID. I put several video links below just in case you need them. One more point. This video is much longer than most of my other videos, so please bear with me. Let's take a look at one example. One day your supervisor walks to you saying, "Here's the network ID. Please create 3 separate networks or subnets for a coffee shop, Sunny Cafe. One is for the office, one is for the front desk and storage room, and one is for the public use." Your task is to list each subnet network ID, subnet mask, host ID range, the number of usable host IDs, and broadcast ID. I put this example below this video so you can copy to your document for your reference as we discuss the process of subnetting. First, let's build a table. This table is the most critical because once we build it, we can easily solve most subnetting questions. And this table has 3 rows. The first row is a subnet with 9 numbers. We start with 1, then 2, 4, 8, 16, 32, 64, 128, and 256. The pattern is each number is a double of its previous number. Okay. The second row is a host. This row tells the number of total host IDs for each new subnet. Start with 256, then 128, 64, 32, 16, 8, 4, 2, and 1. The pattern is each number is half of its previous number, or the second row is the reverse order of the first row. You see, everyone can handle this, right? The third row is a subnet mask. We use shorthand format, starting with 24, 25, 26, 27, 28, 29, 30, 31, 32. Well, we are done. I call this table Sunny Subnetting Table, or simply Sunny Table, because it's a simple, sunny, but a powerful table for subnetting and subnetting a subnet. Now we use Sunny Table to solve the subnetting example mentioned above. Let's go back to the question. You are given a network ID 192.168.4.0/24. /24 is subnet mask. You are required to get 3 subnets. 3 is the key word. Now look at the Sunny table and try to find the 3 subnets in the first or in the top row. Of course, there's no exact 3 subnets, but 4 subnets are suitable because we can get 4 subnets and choose any 3 subnets for Sunny Cafe. So we choose 4 subnets, 4. Let me circle the whole column, ignoring all other columns because we only use these 3 numbers, and we can get all our answers just from this column or these 3 numbers. 4, 64, and /26. 4 means 4 subnets. 64 means each new subnet will have 64 total host IDs, including network ID and broadcast ID. /26 is the new subnet mask for all these 4 subnets. Well, let's list all these 4 subnets information. A network ID, subnet mask, host ID range, the number of usable host IDs, and broadcast ID. Let's find the first network ID. The first network ID is always the original network ID, which is 192.168.4.0. That's easy, right? I use red font to emphasize the last number because the first 3 numbers stay the same across the table. So please just focus on last number in red. We will get next network ID by simply adding 64 to its previous network ID. Therefore, the second network ID is 0 plus 64, which is 64. The third network ID would be 64 plus 64, which is 128. The fourth network ID is 128 plus 64, which is 192. Now, subnet mask for each subnet. Well, They are all /26. The original subnet mask is /24. We are done with the subnet mask column. Now let's list the number of usable host IDs. And we can also find the answer from the Sunny table, which is 64. 64 is the total number of host IDs for each network or each subnet. But the first host ID is reserved for network ID, and the last host ID is reserved for broadcast ID. Thus, the number of usable host ID is 64 minus 2, which is 62. Thus, we write down 62 for all 4 subnets. We are done with the 4th column. Now let's look at the broadcast ID for each subnet. Keep in mind, the last host ID is reserved for its broadcast ID. Therefore, broadcast ID for the first subnet is 63. And we can tell with the reference to the next network ID, 64. Next broadcast ID is 127. Next one is 191. And the last broadcast ID is 255. We can say the broadcast ID equals next subnet's network's ID minus 1. We can also do like this. Once you know the first broadcast ID, 63, and then you can simply add 64 to get the second broadcast ID, and 63 plus 64 is 127, and then add 64 to 127, which we get the third broadcast ID, 191, and then increase by 64 again to get the fourth broadcast ID, which is 255. We are almost done. One last column, the host ID range. A subnet host ID range is any IDs between its network ID and broadcast ID. For the first subnet, 1262 is between network ID 0 and broadcast ID 63. The second host ID range, 65 to 126, is between 64 and 127. The third host ID range, 129 to 190, is between 128 and 191. The fourth host ID range is between 192 and 255, which is 193 to 254. So to keep simple, we only talk about the last number, and because the first three numbers stay the same. That's all. We get all answers. Whew. You can assign any 3 out of 4 subnets for Sunny Cafe. One subnet is wasted, of course. That's the downside of subnetting. No biggie. I want to thank you for following me at this point. You are a very patient person for listening to me with my strong Chinglish accent. Even though the process sounds tedious, but once you get to know how to do it, you can solve any similar questions in no time. I put one similar question below for your practice. I also provide the answer below for your reference. If you have questions, please feel free to leave your comments or ask me questions. I would be happy to help you. In next video, I will go one step further, subnetting a subnet, using the same Sunny table in same sunny way. Please stay tuned. Thank you very much and see you next time.
So that's all for today and see you in my next video. Bye bye.